So let's try to look at some indefinite integrals that are of course a bit different from the usual indefinite integrals that we use dealing with. So they will also involve some inverse trig functions. Okay, so the first example that we are going to look at is let's try to determine the integral of sine inverse of x dx. Okay, so when it comes to inverse trig functions, uh, it's advisable or it's convenient to use substitution. Okay, you can use substitution in some cases. In other cases, you're able to use integration by parts. So what I'd want to do in this case is that I'm going to try to use integration by parts. Okay, so of course, the only thing that we can see here is sine. All right, the only thing that we can see here is a sine, but I'll tell myself, I'll convince myself that there's a 1 here, and of course there is a 1, but you're not just showing it. Okay, so now it's just a matter of us deciding which one is going to be our u and which one is going to be our dv. So in this case, I'm going to let my u be equals to the sine inverse of x. Okay, then my dv will be equals to my dx, such that my du will be equals to 1 over uh, the square root of 1 minus x squared dx there. Okay, so meaning our v will be equals to x. So just in case you are wondering where this came from, so we did this under the derivatives of inverse trig functions. How we get it is this way. Like you have, let's say we have this right angle triangle here. Okay, so and we have a function, an inverse trig function of y is equals to sine inverse of x, such that we can, instead of writing in terms of an inverse, I can say, okay, my x is now equals to sine y. Okay, so if this is our angle here in terms of sine, and we know that in terms of SOHCAHTOA, our sine, okay, our sine theta is nothing but the opposite over the hypotenuse. Okay, and what we have is that we have our x over, we have a 1 here, we're not just showing it as well. Okay, so meaning our opposite is x, then our hypotenuse is 1, making the adjacent to be 1 plus x squared. Okay, so now we want to try to determine how that comes about. So what it is that you have your x, which is equals to your sine of y. Okay, so I have to differentiate this in with respect to y. So meaning I'm looking for my dx dy instead of the usual that we are used to finding the dy dx. So this is going to be your dx dy. That would be nothing but cos y. Okay, so what it is that instead of me having dx dy, remember we are looking for the dy dx, but now we have our dx dy. So this is going to be dy dx, which will be equals to 1 over uh, cos of y. So it's more like I'm trying to make I'm trying to make dy dx the subject of the formula, but in the case where like you have your dy on top, then your dx as the denominator. So that's what you're going to have as your dy dx, such that if we are to look at what we have there from the right angle triangle there, yes, we are saying our dy dx is equals to 1 over cos y. So cos y, remember to say from SOHCAHTOA, cos of theta is equals to adjacent over hypotenuse, and in this case our adjacent, um, and in this case we just say we have 1 over. Okay, so in this case our adjacent is what we have here. Okay, so we can say we are saying 1 over theta, 1 over cos y, so we have like 1 over, so our cos is adjacent over hypotenuse. Our adjacent is what? Our adjacent is the root of what? 1 plus x squared divided by hypotenuse, which is 1, which will still end up giving us 1 over what? 1 over root 1 plus x squared. This is where this comes from. So in case maybe you reach a point where you want to determine what your cos inverse is, your tan inverse, your cosec inverse, your cot inverse, as well as your sec inverse. You just apply the same method, it will still give you the same thing. So that's how you come up with that one, just in case you come across something that's a bit different. Okay, so what will happen is that using integration by parts, so that would be like you have your u dv is equals to uv minus v du. Okay, so in this case, what's our u? Our u is let me try to write it this side. um, okay, so in this case we are going to say um, our u is sine inverse of x, then our v is x, so this is going to be x, um, x sine inverse of x minus um, what are we going to have there? So minus, we are saying our d v du. Okay, so in this case our v is x multiplied by our du, which is 1 over root of 1 minus x squared dx there. Okay, so what will this be? This is going to become x. Maybe before I do that, I want to try to determine which method that I'm going to use to break this down. So what it is that we can also write it in this form, where we have our x sine inverse of x minus integral of x over root 1 minus x there dx. So we have to integrate this part, and we can simply use u substitution there. So we are going to let our u be equals to 1 minus x squared, of which our du will be equals to minus 2x dx. Okay, so we can say, okay, what we now have is that we are going to have our x, x by sine inverse of x minus we're going to have our x here divided by root of u, okay, square root of u multiplied by dx. What's our dx? Our dx is nothing but minus du over 2x, of which we observe that this x and that x is going to cancel out. So what you're going to remain with is that this, in fact, this is going to become positive, because this negative here, okay, this negative is going to multiply that negative, making that rendering that to be a positive. So that would be x by sine inverse of x, that would be plus in fact, I can bring the 2 outside, that would be 1 over 2, then integral of 1 over root u, but I can write this as u to the power negative 1 over what? Negative 1 over 2 du. Okay, so that's what we are remaining with there. Okay, so we just now have to integrate what we have here. So now this is going to be x by sine inverse of x, then we have 1 over 2 here. The integral of that, we are going to have our u to the power negative, we are going to add the 1, so that's going to be positive, to no longer be a negative. That would be like minus 1 over 2, or it's more like minus 0.5 plus 1, that would give us 0.5, which is 1 over 2, the same 1 over 2 down here. Okay, how does this now become? This would be x sine inverse of x plus, so this one is going to become just a u to the power 1 over 2, because we have 1 over 2 here, okay, then we have over 1 over 2, so that would be like 1 over 2 divide by 1 over 2, of which you multiply just by the reciprocal of this, that will become like 2 over 1. The 2 goes, and that's what we remain with. But remember to say we have to write this in terms of x. Okay, so the final answer is going to be, we're going to say the integral of sine inverse of x dx will be equals to x by sine inverse of x plus, what's our u? We said our u was equals to 1 minus 1 minus x squared, remember? So that is now going to be that's now going to be like, we can use this, I think I can use a root, it's still okay. That would be 1 minus x squared Okay, that is what our u is, and we add a constant, and that happens to be the answer that we are looking for. Okay, so it's just a matter of finding the best method that you are able to use. So let's try to look at another example on indefinite integrals. So let's say we have another inverse trig function, but in this case it's a product of two different functions. Um, we have our x squared there multiplying our tan inverse of x dx. So this once again, what to work best here is what is going to work best is integration by parts. So I'm going to let my u be equals to uh, tan inverse of x. So I'm making my u to be tan inverse of x because I know how to differentiate tan inverse. Okay, I know how to differentiate tan inverse. But if I let my dv be tan inverse, I might have a little bit of challenges when it comes to integrating my tan inverse. So I let my u be something that I can easily differentiate. Okay, so meaning my du in this case, using the same similar method that I showed how to come up with a derivative of sine inverse of x, you use the same. You're going to find that your tan inverse will be equals to 1 over 1 plus x squared, like that, dx, of which our dv, we say our dv is x squared, meaning okay, dx there. Then our v will be equals to x to the third divided by 3 there. Okay, so now by like using integration by parts, we're going to multiply our u by our v. So our v is x to the third divided by 3, then that will be like tan inverse of x minus, so we're going to have our v du. Okay, so our v is x to the third divided by 3. I'll just put the 1 over 3 outside here. Then I'm going to have x to the power 3 divided by 1 plus x squared dx. Okay, so now how do we break that one down? So what I can do here is that I can try to use trig substitution. Okay, I'm going to try to use trig substitution because this was going to be is going to be a bit difficult to use substitution, unless if maybe I had like x squared on the numerator, then 1 plus x cubed on the denominator. It was going to be much easier for me to work with use substitution. So I'm going to use trig substitution. So I'm going to say, okay, in this case my x is equals to tan theta. So meaning my dx will be equals to sec squared theta d theta. Okay, and again I would want to show what my theta is in advance. My theta is equals to tan inverse of x. Okay, so how does this now become? That would be x to the third divided by 3 tan inverse of x minus 1 over 3 there. Okay, so we have said our x is tan theta, so meaning this is going to be tan tan to the third theta divided by 1 plus, that to be tan squared theta multiplied by dx, which is what sec squared theta d theta. Okay, so this is going to be x to the third divided by 3, that would be tan inverse of x minus 1 over 3. Okay, so how does this now become? So you observe to say this part and that part are going to cancel out, because we know that sec squared of theta is equals to 1 plus tan squared of theta, so we can get rid of that part. Okay, so that just comes from that identity, sec squared theta minus tan squared theta is equals to 1. So when you make sec squared theta the sub of the formula, that's going to be 1 plus tan squared theta. That's why that is cancelling out. Okay, so what remain with is tan inverse, tan to the third theta d theta there. Okay, so what we observe now is that we are able to use the reduction formula to try to break this down. Okay, to try to break that down. Okay, so now just to remind ourselves, we know what we did when it comes to determining the reduction formula for tan, and I don't really think I'll go through that process again. I'll just have to write it down, like um, the final reduction formula for tan. It's just remind ourselves, it's tan like that. Dx will be equals to tan n minus 1 of x divided by n minus 1. Okay, n minus 1 minus integral of tan n minus 1, n minus 2 of x dx. So that's the reduction formula that is related to tan. Okay, so how is this going to be? That is going to be equals x to the third divided by 3 tan inverse of x minus 1 over 2, 1 over 3 rather, then open bracket. So when I use the reduction formula, this is going to appear like this. Remember to say we were saying tan n minus 1, since our n is a 3, that would be tan to the third, tan to the second theta divided by 2 minus, because we had like n minus 1 on the denominator again from the formula, then integral of we are supposed to say tan n minus 2 theta d theta for this part, but because our n is a 3 minus 2, that will give us a 1, so we are going to remain with tan theta d theta. Okay, so now how does this become? That will become x to the third divided by 3, then tan inverse of x minus that's going to be tan squared theta divided by 6. Okay, divide by 6 there, then that's going to be plus 1 over 3. Then the integral of this one is nothing but negative ln of cos theta. Okay, absolute value of cos theta there. Okay, so now to finalize this is more like the integral itself, but remember that we have to write this in terms of x, because we have some x, we have a theta somewhere, and we have to write it in terms of x, and we said our theta is equals to tan inverse of x, because we said our y, no, we said our x, not y rather, we said our x was equals to tan inverse no, we said it's equals to tan theta, so meaning our theta was equals to tan inverse of x, like that. So we can now say, okay, the integral of x squared by tan inverse of x dx is equals to, so that would be like x to the third divided by 3, that would be tan inverse there of x minus what do we have? We're going to have tan squared, where there's theta, I'm going to put tan inverse of x divided by 6 minus 1 over 3, I'm multiplying by that minus there, so that would be ln of cos, let me put absolute value signs there, so that would be cos, open bracket, where there's theta I put tan inverse of x, I close, and like that, then plus c as a constant, and this part here is the answer that we are looking for. Okay, so it's just a matter of remembering some identities, remembering some other methods of integration, such as, because in this case we have used trig substitution, we have also used integration by parts, so it's very important that we we familiarize ourselves, or remind ourselves what we did under trig substitution and any other method that we used. Okay, so the other example that we are going to look at is let's say we have x multiplied by root of 1 plus x dx. Okay, so this is a little straightforward. uh, what I'm going to do is I'm going to try to use substitution and see if it can work out. Okay, so let's say let's let our u be equals to 1 plus x. Okay, meaning our du will be equals to dx. Okay, that's what's going to be our du. So we can say our x multiplied by the root of u. What's our dx? Our dx is u, but remember we have a u and we have an x there, so this x has to be in terms of u. So what can I do? I know that my u is equals to 1 plus x, so I have to determine what my x is. So my x will be nothing but u minus 1. That's what going to be our x. So this is going to be u minus 1 multiplied by root of u du there. Okay, so what happens is that I can distribute that inside. So, or perhaps before I do that, I can write this as my u minus 1. Then this is going to be our u to the power 1 over 2. That's the way it is. Then when we distribute, we're going to have our u multiplied by u to the power 1 over 2, of which the powers we are going to add them. That will be like 1 plus 1 over 2. How is this going to be? This is going to be 3 over 2. Okay, yeah, so this is going to be u 3 over 2 minus u 1 over 2 there, du, of which I believe that is okay when it comes to integrating it. So what it is that we are going to get that the integral of x multiplied by root of 1 plus x dx is equals to. So this part, let me break it down here so that there I just write the final answer. So this is going to be like u to the power 3 over 2 plus 1. That will give us 5 over 2. That will give us 5 over 2 there. Okay, divide by 5 over 2 minus, this is going to give us u 3 over 2 divided by 3 over 2 there. So what you end up having is that in fact, let me not conclude just here, because there's another step that we have to go through. So that will become 2 over 5 u to the power 5 over 2 minus 2 over 3 u 3 over 2 there. So remember to say we have to write this in terms of x. We said our u was equals to 1 plus x. So I can say therefore the integral of x multiplied by square root of 1 plus x dx is nothing but 2 over 5 open bracket 1 plus x to the power 5 over 2, then minus 2 over 3, then 1 plus x to the power 3 over 2 plus a constant, and that's the integral there. Okay, so we can still look at the fourth example. So let's say we are looking for the integral of cos x to the power 1 over 3. I guess we are raising the cos to some value, but in this case what is raised to some number other than 1 is an x itself, is like part of the angle. So what it is here, is that you can use substitution as well. It's going to work out just okay. So what's going to be is that you're going to let your u be equals to your x to the power 1 over 3. Okay, 1 over 3. So meaning your du will be equals to 1 over 3 x to the power that's supposed to be negative 2 over 3, but we can write it as 1 over 3 x to the power 2 over 3 dx. Okay, so we can say this is going to be cos u. Okay, that is going to be cos u. Then our dx is nothing but 3x to the power 2 over 3 du. Okay, but remember once again, we have an x and a u term within the same kind of like integral setup, but we want to try to, it's either we write it in terms of x, or both in terms of u. But I know what my, I can find what my x is, because I want to write this in terms of u, because I want to integrate with respect to u. So what it is that you have your u is equals to x to the power 1 over 3. So you have to, more like you have to make x the subject of the formula. So what it is that I'm going to multiply both sides by what? By 3. Okay, 1 over 3 by 3, it will be 1. So meaning our x will be equals to u to the power 3. Okay, that will be like cos u multiplied by, in fact, we can simplify our work. We can say, okay, we can put the 3 outside. So that will be cos u by, what's our x? We have found out that our x is u to the power 3. That will be like u to the power 3. We close the brackets. We still have that part, which is the 2 over 3 du. So the 3 goes and the 3 goes. So what remains with is that we are looking for the integral of 3 by the integral of cos u by u to the second. Okay, u to the second there. So of course we still have the du. So what where we have reached here, we are going to use integration by parts. It will be much convenient. So what it is that I've used a lot of u here, and we know integration by parts that it has to do with a v and a u. Okay, so I don't want to confuse myself by bringing in another u. I have to try to use a different letter for the integration by parts equation. That will make things much convenient. So instead of, remember to say for integration by parts, we say it is your u dv is equals to uv, okay, uv minus v du. So I'm going to write it as n dm is equals to my nm minus integral of m dn, like that. That's what I'm going to use instead of using that, because I've already used the u anyway. So I don't want to confuse myself there. Okay, so what it is that I'll say, okay, I'll let my n, okay, I'll let my n be equals to u squared. So meaning my dn will be equals to 2u du. Okay, then my m, not my m here, I'll say my dm will be equals to, cos u du. Then meaning our m is equals to sine of u. Okay, so remember to say we are saying our n by our m, those were in place of our u and our v. So that would be u squared sine u minus integral of m dn. Okay, m by dn. So I'll put the 2 outside here. So that would be like our u sine u there. Okay, u sine u du. Okay, so again I use integration by parts for the second time. So I'm going to let my n again be equals to u. Okay, so meaning my dn will be equals to du. Then my dm will be equals to sine u du. So meaning our m is equals to what? Minus cos, because the derivative of cos is positive. The derivative of cos is negative sine, but for it to be positive, meaning it was negative cos. Okay, so what we come up with here is that we are going to say this will be equals to u squared sine of u minus 2 open bracket u by minus cos, that would be minus u cos u there, minus integral of m times dn. That is going to be minus, but because of the minus that we have here and the minus that I have there, this is going to become a positive cos by dn. What's our dn? Our dn is a u. Okay, okay, but we'll have to remember what our u is. We need to replace at the fine when we're almost done. So we have found that our u squared, that would be sine u minus, that would become plus, in fact, 2u cos u minus the integral of cos is sine, that would be sine of u. Okay, so that become minus sine minus 2 sine of u there. Okay, but you're not yet done, so you have to express this in terms of u. So I can say, okay, therefore the integral of cos x 1 over 3 there dx is equals to, what's our u? We said our u is oh wait, I forgot something. We are supposed to have a everything I'm multiplying by 3, remember? Yeah, so this is going to be 3, yeah, like that. So 3 open bracket. So our u, we said is this is what our u is. So we, where there is u here, replace with that. That is going to give us x to the power 2 over 3, then sine x 1 over to the power 1 over 3 plus 2 x to the power 1 over 3 cos, that will be cos, instead of cos u, I want to have cos x to the power 1 over 3 minus 2 sine x to the power 1 over 3 there. We add the what? We add the c, and that's the integral that we are looking for there. Okay, so now let's say we have we now have something that's a bit different. Instead of trig, let's say we have e to the power root x. Okay, that is looking cool though. Yeah, so we can use substitution as well here. So our u is going to be equals to root of x, which is nothing but x to the power 1 over 2, x to the power 1 over 2. So meaning my du will be equals to 1 over 2 root what? 2 root x dx. Okay, so this is going to be e to the u, then our dx, we have found out that is 2 root x du. So once again, I know that my u is equals to x to the power 1 over 2. First, I have to determine what I have to make my x the subject of the formula. So meaning here, this is going to be u squared will be equals to x. Okay, u squared will be equals to x there. Okay, so after I make, yeah, that will be what our u will be. Well, that's going to be our x. So this is going to be e to the u multiplied by 2. Then that would be like, we are supposed to say x. Our x is u squared there, then to the power 1 over 2 du. So remember to say this 2 and that 2 is going to cancel out. So we just remain with a what? We just remain with a u. So, and I'll put the 2 outside here, and you'll have that as our what? As our u. So remember to say, looking at it the way it is in this case, we are going to use integration by parts. Once again, I'm just going to use n and m inside of u and v, because I already have a v. I already have a u, and I don't want to confuse myself. So here I'm going to say I'm going to say my n is equals to u. Okay, maybe try to use this color. I'm going to let my u be equals to, not u, my n be equals to u. Then dn will be equals to du. So meaning our dm will be equals to e to the u, meaning our m, in fact, is d with du there. Then our m will be equals to e to the u again there. Still be the same. So by integration by parts, our n times u times m, that will be u by e to the u minus integral of dn by m dn. We're going to have e to the u, then our dn is du. Okay, this is going to be u e to the u minus e to the u. Okay, so remember to say our u is equals to what we have there. So I can say therefore the integral of e to the root of x, like e raised to the power root of x dx, is equals to my u, which is what, x to the power 1 over 2. But in this case, let me try to write it this way. I think there's something that we have forgotten. Yeah, we have a 2 here. Can put it there. Yeah, so that's going to be 2. Okay, that's going to be a 2 there. Then root x, then e to the root x minus 2e to the root x plus c, and that's the integral there. Okay, so we have seen the importance of use substitution as well as integration by parts. Okay, so one thing that we have to always remember is that it's not always the case that whenever you're using use substitution there will be something that you're able to cancel out. Sometimes you can have some two variables, such as maybe you have a u and an x in the same kind of like setup, but you can still write your your x in terms of a u by making x a subject of the formula and determine what it is in terms of u, and that would be much easier. Okay, so let's say we have the integral of 1 over looking for the integral of 1 over x root 1 minus, not minus but plus x here, let's use plus, then say dx there. So even here I'm still going to use your substitution. So my u will be equals to I will let my u be equals to 1 plus 3x. Okay, so when I differentiate that, my du will be equals to something like a 3 divided by 2 root 1 plus 3x dx. So once again, I observe to say when I write this in terms of u, I'll still have an x here, so meaning I have to write that x in terms of u. So I will try to make my x the sub of the formula from there. So when you make it a subject of the formula, that will be x will be equals to x squared minus 1 over what, over 3. So that would be 1 over our x, it's say 1 over our x. We have found that our x is u squared minus 1 over 3, then that's a u there. Okay, then what's our dx? Can do better than this. So we say 1 here, 1, then we say over, we have our x, which is u squared minus 1 over 3, then we're supposed to have a u here, which is this one, and we are just going to put it there. Then our dx, okay, our dx is we multiply by 2 root 1 plus 3x, okay, 1 plus 3x there, divide by what, divide by a 3, then that would be du. So we have another one that is in terms of x, but remember to say our u is equals to that. So these two, this one and this one, they are the same. Okay, so we can cancel them out. So what remains is that we have a 2 on the numerator and a 3 on the denominator. Okay, so what about the are we also able to cancel out the 3? Perhaps we are able to. We can also cancel out this 3 as well as that 3 there. Yeah, we're able to do that. So meaning what you're going to remain with is the integral of we're still going to have a 2 outside, that will be 1 over u squared minus 1, which is that part, then with a what, with a du there. Okay, so going on to integrate that part. So this it's a bit complex in some way with the method that I'm going to use. So I'm going to write this in terms of I'm going to write this as 2. That will be 1 over that's a difference of 2 two squares, that is going to be u plus 1, then that will be u minus 1, then we have du. So I can break this down into its equivalent partial fractions. So this is going to now be, if you break it down into its equivalent partial fractions, that would be 2, that would be 1 over. Okay, so when you break it down to be something like, we have a u minus 1, okay, let me say plus. Okay, when you break it down, that's what you're going to have. Then that would be minus 1 over 2 u plus 1 with a du there. So you just have to break this down into its equivalent partial fractions, and that's what you're going to get. So now we go ahead and integrate that. So remember to say this 2 is going to go and that 2 is going to go, this one is also going to go, okay, because it's more like it's common on both the denominators, and you bring it out is to cancel out the 2 that we have. So what we end up having is, when we integrate, we are going to find that what we have is the natural log, to be like the natural log of the absolute value of u minus 1, okay, because minus natural log of u plus 1, and we close like that. But remember to say we have to write it in terms of what? In terms of u, and this is what our u is. This is what we have this as our u. Okay, so we can now say this is now equals to what? This is now equals to ln of our x. Okay, we said our u is root of 1 plus 3x minus 1, like that. We close minus ln of, then that would be root of 1 plus 3x plus 1, because we close plus c there, and this is the integral that we are looking for. Okay, so let's look at the last example in this tutorial. Okay, so let's say we have we're looking for the integral of 1 over 1 plus x minus 1 to the power 1 over 4. Okay, so in this case, I'm going to try to use substitution. So I'm going to say my u will be equals to my x minus 1 to the power 1 over 4, of which if you differentiate that, our du will be equals to 1 over 4 x minus 1 to the power 3 over 4 dx. Okay, once again, I believe I'll have an x somewhere. Okay, I'll have an x somewhere, so I have to maybe write make the x the sub of the formula at this point. And you make x the sub of the formula, what you're going to get is that your x is going to be equals to your u to the power 4. Okay, your u to the power 4 plus 1. Okay, so this is going to be integral of 1 over 1 plus u to the power 1 over 4 there. No, that's just going to be a u. Yeah, that's going to be just a u there. So that would be 1 plus u multiplied by our dx. Our dx is nothing but 4. Then we have our x. Remember, this x here, I can write it in terms of what I have there. That is going to be u to the power 4 plus 1 minus 1. That's going to give us just a u to the power 4. Okay, u to the power 4 raised to the what? 3 over 4 du. Okay, so this one goes and that one goes. What do I remain with? I remain with a u to the power 3, but we have a 4 here, okay, which is this one. So that's going to be u to the power 3 divided by u to the power 3 divided by 1 plus u there du. Okay, so we are not yet done. What method then are we able to use? What method are we able to apply there to make sure to say we do with that integral there? So what I'll do here is that let me try to use what method can work best. Let me try to use a substitution, but in this case I won't call it u substitution because I already have a u somewhere. Let me call it n substitution, where I'll let my n be equals to 1 plus u, which is my denominator. Okay, so meaning my dn will be equals to du. Okay, so now I can bring this down. Okay, so can put it there. So we say 4 here, integral of this u here. Okay, so I'm going to write it in terms of let's try to write it in terms of n, and our n is equals to, that's what we have as our n, so meaning our u will be equals to n minus 1. Okay, so that is going to be n minus 1 to the third divided by what I have on the denominator to be what? To be n. Okay, that will be n. So our du, we have found that our du is equals to dn. Okay, then what method are we able to use here? So I think what I'll do here is that I'll just expand what I have, because I've made it convenient enough that I only have a single term on the denominator, such that if I expand, then I'm just going to write each term individually, then I divide by n, then I see if I'm able to cancel out, and I believe integrating those will be much easier for me. So that would be like 4 integral of, if you expand this, okay, because this is nothing but n minus 1, n minus 1, n minus 1, like that. Okay, so when you expand that, what you're going to come up with is n to the power 3 minus 3n squared plus 3n minus 1. Then I'll divide all of them by each of them by n, 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 and n there. Okay, of which when you try to take care of, like, you cancel out, that's just going to be n to the second. Okay, n to the second minus 3n plus, or perhaps let me just write it the way it was, so that at least, so this will be 3 over, n to the third over n, then minus 3n to the second over n plus 3n over n minus 1 over n dn. So this is going to be 4. That would be n to the second minus 3n plus 3, okay, plus 3 minus 1 over n dn. Okay, so when we integrate that, what you're going to get is something like 4 open bracket, that would be n to the third divided by 3 plus n to the second, 3n to the second divided by 2 there. Wait, that's supposed to be a minus. So 3n to the second divided by 2 plus 3n minus ln of absolute value of n, like that. But remember, we started all the way from this. We are supposed to express this in terms of x. So now we can say the integral of okay, let me start from this side. Okay, we can say the integral of 1 over 1 plus x minus 1 to the power 1 over 4 there dx is equals to, so that would be like 4 open bracket. So here where I have my n, I write my n in terms of my u, then I also write my u in terms of my x. So here, instead of having n, we are going to say our n is 1 plus, what's my u? My u is x minus 1 to the power 1 over 4 divided by what? Divide by 3. Divide by 3. But looking at what I have here, this is raised to the power 3, and you write it like that, minus 3 over 2 open bracket. My n is 1 plus u. My u is x minus 1 to the power 1 over 4. Then I'll put squared there. Okay, plus 3. What's my n? My n is 1 plus. What's my u? My u is x minus 1 to the power 1 over 4. Okay, then what else? Minus natural log of u, natural log of n, absolute value of n. So the absolute value of n, our n is 1 plus u. Our u is x minus 1 to the power 1 over 4. We close and it becomes like that, plus what? Plus a c, which is our constant. And that's simply how we come up with the integral for that question. So one thing, if you are to pick anything from what we have done, from the questions that we have done, is how we are able to manipulate u substitution. Like when you're integrating, it's not really, we're no longer dealing with basic integrals. Like sometimes you have a combination, like when you use substitution, at some point it requires you to use maybe trig substitution, or you have to do integration by parts. And what we have learned is that sometimes it's not always that when you use substitution you're going to cancel out something. That's not the thing. You need to remember that at some point you are able to, if you still have a term that's not in terms of u, you can try to write that term in terms of u, and you're able to, I believe it to be much easier. So that's all in this video. Thank you very much for watching.